Hello friends, I am Krishnakant Daga, studying BTech second year ECE department from Spurti Engineering College. Today I am going to discuss about singleton frequency modulation. First of all, what is singleton frequency modulation? Singleton modulation is nothing but sending only one message signal to the transmitter. Now coming to the derivation part, we know that SFM of t is equals to AC cos 2 pi FCT plus 2 pi kf integration of m of t into dt. This is the standard equation of frequency modulation wave with respect to time domain. Now let us take m of t has am cos 2 pi fm of t. This is the standard equation of the message signal. Here now AC is nothing but the amplitude of carrier signal. FC is nothing but the frequency of carrier signal. M of t is the message signal and KF is frequency sensitivity factor. Now we know that the instantaneous frequency of frequency modulated wave is Fi of t equals to Fc plus Kf into m of t. Now Fi of t equals to Fc plus, substitute this m of t over here, we get Kf into am cos 2 pi fm of t. Now let us assume that del f equals to Kf into am. This del f is nothing but the frequency deviation factor. Frequency deviation factor. Frequency deviation factor is nothing but which represents the maximum departure of instantaneous frequency of FM wave from carrier frequency. Now we know we have Fi of t equals to Fc plus del f cos 2 pi Fm of t. But we know that Fi of t equals to 1 by 2 pi d by dt of theta of t. This is the instantaneous frequency of angulated wave. Now if we send this derivation over LHS, it becomes integration. So we get theta of t equals to 2 pi integration 0 to t Fi of t into dt. Now substitute Fi of t value. We know that Fi of t equals to Fc plus del f cos 2 pi fmt. Consider this as equation 1 and this as equation 2. Substitute equation 1 in equation 2. That implies we get theta of t equals to 2 pi integration 0 to t Fc plus del f cos 2 pi Fm of t whole dt. Now theta of t equals to 2 pi Fct plus del f sin 2 pi Fmt by 2 pi Fm into 2 pi. Solving this integration part, after solving this we get this equation. Consider this as equation 3. Now here 2 pi and 2 pi gets cancelled, so we get theta of t equals to 2 pi Fct plus del f by Fm into sine 2 pi Fm of t. Now we know that the modulation index is always represented by beta. It is nothing but the ratio of frequency deviation delta f to the modulation frequency Fm. This is known as beta. So we can write beta as del f by Fm. So by substituting this value, substituting this beta value in the equation, let us consider this equation 4. Substituting the beta value in equation 4, we will get theta of t equals to 2 pi fct plus beta sine 2 pi fm of t. This is the final equation. Now by substituting this theta of t in the standard equation of singleton frequency modulation, that is SFM of t, we will get this standard equation as AC cos of, we have AC cos of theta. So in place of theta of t, substitute this equation. So finally we will get the equation as SFM of t equals to AC cos of 2 pi fct plus beta sine 2 pi fm of t. This is the final equation of the singleton frequency modulation.